Okay, I'm here at the YK Zone at Moodle. I'm going to log in, and I'm going to take the test and give some explanations on some of the common questions there. Okay, the test I took Friday is going to be way over here on the bottom, 928 on week 5. Okay, I'm going to attempt the quiz. Okay, here's number 1. Aphids are eating the roses in Jenny's garden. Okay, she wants to test some household chemicals to see if they will kill the aphids. She uses bleach, ammonia, and dishwashing liquids in equal amounts. She will evaluate the aphids population after 1 week to see which chemical killed the most aphids. What is the independent variable in the investigation? The independent variable is always what we change in the experiment. Okay, so in this case, she uses bleach, ammonia, and dishwashing liquid in equal amounts. So select 1. The number of aphids killed? No, that's the dependent variable. That's what we measure. That's what she wants to see if she can kill those off. Okay, B, the number of roses on the plant? No, that doesn't really matter. C, the amount of chemicals used? No, we're not. They said that they use equal amounts, so that's not going to be the answer. D, the types of chemicals used? Yes, there are different types, so that would be my answer. Okay, next. Okay, the table shows the results of an experiment. What most likely was being answered by this activity? Okay, select 1. Which material requires the greatest volume in the electric circuit? Okay, if we look at this table, material conducts electricity or no? Yes or no? Okay, so was the problem that they were trying to figure out which material requires the greatest voltage in an electric circuit? No, we don't see here about voltages or anything, so it can't be that one. How warm do materials get when placed in an electric circuit? Well, no, we're not measuring temperature. There's no temperature reading there. C, can an electric current be used to distinguish metals from nonmetals? Yes, conducts electricity. Copper is a metal. Glass is a nonmetal, so yes, you can use that. But we read all of our selections here. D, will an electric current change a metal into a nonmetal? Nothing's being converted here. So the best answer is, based on our table and our data, is going to be, can an electric current be used to distinguish metals from nonmetals? Now notice it's written in cause and effect. Can an electric current, using an electric current, effect, what is its effect? Can you use it to distinguish between metals and nonmetals? It's also written in cause and effect. So that's one of the rules that we need to remember on these. Next. Okay, number 3. A mineral supplement designed to prevent a common cold was given to 2 groups of people during a scientific study. After 8 weeks, neither group reported a case of the common cold. Which of the following would have made the outcome of the study more valid? Okay, so they had group 1, group 2. They both gave them that medication. So A, give the supplement to both groups for only 6 weeks. No, that really doesn't matter. Test 1 group with 150 milligrams of the supplement. No, not really. It's just making a different amount. Create a 3rd group that received 75 milligrams of the sample. No, of the supplement. Or D, create a 3rd group that does not receive the supplement. Okay, for us to determine whether the independent variable in this case, which is the mineral or the supplement, helps people with this common cold, we need to have a control group that does not have our independent variable. Okay, so our independent variable is on our experimental group, which this is shown here, but this does not have a control group. So we really don't know whether it did cause a change or it did not cause a change. Therefore, the best thing to do is to create a 3rd group that had no supplement that they received, maybe a sugar pill or something, a placebo. So D was the correct answer. Okay, similar springs of elodea were placed in 4 test tubes. Each test tube contained water but different concentration of salt ranging from 0 to 3%. The length of each sprig was measured after 10 days. Which of these questions can best be used to answer this question? This experimental setup. Okay, so here's the experiment. What was it that they were trying to solve? What was the problem, or what is the question here? Okay, 1, can the amount of salt in water help elodea avoid disease? No, the water is the same in all of them, so that can't be it. 2, does the amount of salt in the water affect the elodea growth? Well, we see they did change the salt concentration, right? Okay, so that is definitely a red flag there that possibly is the answer, because what changes in an experiment is our independent variable. Will Elodia increase the amount of salt in water? Okay, in other words, is this producing more water? No, that's not what we're changing. The water is all the same here. Last one, what happens to salt as Elodia uses water? Okay, where we don't, based on this information here, the only thing we see is this change here in the concentration. So that has to be what they're trying to figure out, whether it affects this plant in some way. Okay, so the best answer for this one would be, does the amount of salt in the water affect Elodia growth? Okay, number 5, which of the following are written in cause and effect form? Now, this one should have had 2 answers here, so it was my bad. If the students let me know and email me, message me, I'll change this one. But this actually had 2 possible answers. You could have put problem statement, cause and effect, or hypothesis. A hypothesis is also written in cause and effect. Either one of these would be okay. So I'm going to have to go back and give credit to students that had that one correct, which is not a big deal. Okay, observations are not written in cause and effect. Procedures are not written in cause and effect. Observations are just things that we see. So the car is red. Okay, so we don't say if the car is red. If it's a car, it's red. No, it's just an observation. Procedures are just telling the steps of how things happen. So here you could either put problem or hypothesis, and it would have been correct. Okay, the table shows the results of an investigation. What information should be used in the column headings marked X? Okay, select one. Okay, here we have soil temperatures, we have germination rate, and average germination rate. Okay, so should we put the number of seeds? No. Okay, should we predict the predicted value of the results? No, that doesn't make sense. Average of the data in each column? No, this is the average over here. Trial number? Yes. Germination rate? What was the germination rate in trial 1, trial 2, trial 3? So X should be D. Okay. So we have another picture here. This one wasn't too bad, but let me go to the one that's like the ones with the big pictures that students. Well, this one was another one that was kind of like a problem. Which is an example of a bias in an experiment? Now, for most of the students, except for 6th period, this wasn't written correctly, so they got their credit back. Okay, so which is not an example of a bias in an experiment? Okay, not having the independent variable in the experimental group. No, we have to have an independent variable in the experimental group. Faulty equipment. Yes, that's a possibility. A scientist making his partners repeat the experiment? No, we need trials. We need to have trials. D, having constant variables present in every trial? No, we want constant variables in each trial. We want to keep everything the same except our independent variable. So the answer for this one should have been B. Okay, number 9. Some snapdragon seeds were studied in an experiment shown. The seeds were placed on a dish lined with a moist paper towel. Which of these is an independent or manipulated variable in the experiment? Again, what we see changing here is what? We're seeing the temperature change. So the temperature change has to be what is your independent variable. Now I can also ask, okay, what is the constant variable in this experiment? And they should be able to tell me the constant variable is the amount of seeds, because that's the same number in each of the petri dishes here. Okay. If I ask them, okay, what would be the control group? We would have to say the control group would have to be a standard like room temperature, or that has to be given out there. But here we don't have any control group. We just have changing temperatures. So I'll put pictures and ask different questions that pertain to this experiment. Like, what is the dependent variable? What is the independent variable? Like in this case, what would be the dependent variable? It would be the growth of the little seeds. So it's what we measure. So all these possibilities I can ask when we do these tests. Okay, a valid study would include a control group containing, okay, here's a picture, it's coming up, it's loading. Okay, this is a picture. Now, some of the kids did not have this picture show up on their test, so this wasn't counted against them, but this might come up on another test. So it says here, a valid study would include a control group containing what? Okay, so here we have the experimental control group. Experimental group, 5%, 10%, 50% hormone, and then they have their seeds here and soil. So what would it have to do to this side to make it a good control group? Well, a control group has to have everything identical as the experimental group except your independent variable. Your independent variable in this case is the amount of hormone. So we have 5, 10, 15. So for this to be a good control, I would put all of the same seeds in there and the soil amount and the water amount, except I would put no hormone because that's the independent variable over here. Control group does not have our independent variable. So let me see the selections. Water only, no, that would not be sufficient. Bean seeds, tomato seeds, sunflower seeds, and water. That sounds good. C, water and 2% root hormone, no. D, bean seeds, tomato seeds, sunflower seeds, water and 1% root hormone. You're introducing different concentrations that would not work. So the answer for this one would be bean seeds, tomato seeds, sunflower seeds, and water because they don't without the hormone, which was the independent variable. Now I could also ask them what would be the dependent variable. Dependent variable would obviously be how much these little plants grow. So any of those kind of questions I'll ask. I can ask them what is a constant variable. Okay, well they use the same type of pot, they use the same amount of water. So any of those questions I can ask them. Okay, next. Okay, here we have this little story. They have to read it, and then they have to tell me, identify this information. If you were to set up a table for this experiment, the strength of the squirrel would be placed on the first column. Okay, when we do a table in science, the first column is always going to be our independent variable. Okay, like the trials that we use, the particular thing. The dependent variable will always be what we measure, and it's usually going to be on the right side of the column. So if you were to set up a table, the strength of the squirrel in this case is what we're measuring, so that has to be our dependent variable. So when we do a table, it would be placed on the right side. So the strength of the squirrel would be placed on the first column? No, it would be placed on the second column. So we would say, in this case, false. Okay, a good hypothesis statement for this experiment would be squirrels get stronger when they take squirrel mater juice. Okay, so in this case, Bart gives them that juice to see if it makes the little squirrels stronger. So let's see. Good hypothesis statement: squirrels get stronger when they take squirrel mater juice. This is not a good hypothesis. It's not written in cause and effect. What is actually happening here is that you're putting the effect and then the cause. Squirrels get stronger. Stronger is what we measure. So that is the effect. The cause is the squirrel mater juice. Hypothesis statements are always written in cause and effect. For this to be correct, it would have had to say squirrels taking squirrel mater juice will get stronger. So this is going to be a false statement. Okay, squirrel strength, what would it be? Okay, squirrel strength is our dependent variable, is what we measure. Okay, next it's going to be how far the squirrels push the block squirrels with squirrel mater juice. The squirrels that take the squirrel mater juice are going to be our experimental group. Okay, how far the squirrel pushed the block is the independent variable because that is what was changed. No, what was changed was whether taking the juice or not taking the juice. So that is definitely a false statement. Okay, squirrel mater juice, that would have to be our independent variable. Okay, because that is what we're changing. We give some of the squirrels the juice, some of them we don't. Squirrels who took the squirrel mater juice. Oh, okay, I gotta go back here. Oops, sorry. Squirrels without the squirrel mater juice, that's our control group. There it is.